So I'd like to give you the general formula to find a derivative of an inverse function. It looks really complicated and intimidating, and maybe it is a little bit intimidating, but we'll do some examples so that we can practice. So basically, if you have a function f that is differentiable and has an inverse function, then we have this formula right here for this inverse function. So derivative of an inverse is going to be 1 over the composition of the derivative of your function evaluated at that inverse. So let's do an example so hopefully that can clarify things a little bit. For our first example, we have f of x equals 4 minus 3x plus e to the x. We are going to find the derivative of f inverse of x evaluated at x equals 5. By the way, note that this notation here is the same as the one that we have in our definition of a derivative. It's a different notation, but it's the same meaning. So we're going to be finding the inverse. Then this thing right here with the line means evaluate at x equals 5, basically. So let's try to write out what we're actually trying to find. So we know, based on our definition, that we're trying to find this, f inverse, and then derivative evaluated at 5. And we know, based on our definition, that we're going to find the derivative and evaluate it at the point where our inverse is equal to 5. This still looks pretty intimidating. First thing we're going to do, though, is we are going to figure out what is the value of the inverse when x equals 5. So I want you to recall that usually we have that y is equal to f of x. Now, if you take the inverse of that, if you were taking the inverse of both sides, an equivalent way to write this would be f inverse of y is equal to x. So basically, what the value for f inverse of 5 is you are going to be finding x when y equals 5. So I know it's really confusing. We had an x equals 5 right here. I think that I lost my x equals 5 there. So we have a y equal, so we're finding x when y equals 5. Basically what I'm going to do now is I'm going to take this equation. I get 5 equals 4 minus 3x plus e to the x. I need to find x there. That x value is going to be what I get when I have the inverse evaluated at 5. So this one, the other thing about this problem that's also hard is you get 1 equals negative 3x plus e to the x. This one would not be solvable without a graphing calculator, and you certainly are welcome to you're welcome to graph y equals negative 3x plus e to the x and see where what x value gives you a y of 1. The other thing you might notice is if you work backwards, you can figure out that when x equals 0, your y value is equal to 1. Because if I plug in 0 for x, the 3x term goes away, e to the 0 is 1. So this is telling me that my f inverse evaluated at 5 is equal to 0. So let's go back to my original thing. So now I know that this part right here is now going to be 1 over f prime of 0. So that's something I'm now able to find. So now that I have this, I need to find the derivative of my original function. Hopefully you remember how to do that. You end up getting negative 3 plus e to the x. So once I evaluate that at 0, I get negative 3 plus e to the 0, or negative 3 plus 1. That gives me negative 2. Not quite done with this problem, but now I know that my answer is 1 over negative 2, so I get negative 1/2. I'd like to do another example, and I actually think this one might be a little bit easier than the last one. So we're going to find the inverse of this function evaluated at x equals 2. So again, our inverse of that function is, this is the same notation as we had before, and we're going to find 1 over the derivative of the inverse at 2. So if you remember in the last example, this value right here, the inverse evaluated as 2 at 2, is actually going to be equal, it's going to be equal to the x value when y is 2 in the original function. So I actually gave you something to help you out. I gave you f of 1 equals 2. If you want to use that, if you know how to use that already, you can. But I will show you what we're actually looking for. We're looking for when we want to figure out when is this function equal to 2, and we actually have that above. So we know that in that case, the x is going to be equal to 1. I know this looks confusing because right here we have x equals 2. This x is in the original function, this x is in the inverse function. So they're not the same thing. The x in the original is equal to the y in the inverse and vice versa. So now what we have is that this is equal to 1 over f prime of 1. That's actually not that bad to find. You're welcome to pause the video and just do that on your own. You do find that f prime of x is equal to 3x squared plus 2. So f prime of 1 is equal to 5. So my answer is 1/5.